All right, we're about to take a journey to some of the most extreme places you can possibly imagine, right here in our own cosmic backyard. We're going to explore worlds that are defined by unimaginable fire and, you guessed it, truly alien ice.
So, you think Earth's weather is extreme, right? Hurricanes, blizzards, heat waves, and yeah, they definitely feel extreme to us. But honestly, on the grand scale of the solar system, our weather is pretty tame. Let's go see what real extreme weather looks like.
We are talking about things like lava lakes that are bigger than entire countries, and snow that literally builds an ice shell from the bottom up. It's a great reminder that while the laws of physics are the same everywhere, the results can be just spectacularly different.
So our journey begins now. We're going to travel from the hottest, most violent places we know of, all the way to the coldest and most mysterious. This is a story of fire and ice on a scale that's going to completely redefine what you think is even possible.
Our first stop is a moon orbiting the gas giant Jupiter, and this is Io. Now, Io is, hands down, the single most volcanically active body in the entire solar system. It's a world that's just in a constant state of eruption, a true inferno. And that's not an exaggeration. Scientists themselves compare Io to Mustafar from Star Wars. The lava planet where Anakin had his bad day. Its surface is just covered in hundreds of volcanoes, and a lot of them are spewing fountains of lava miles into space.
So what's powering this crazy volcanic engine? Well, it's all about gravity. As Io orbits Jupiter, the colossal planet's gravity is constantly squeezing and stretching it, over and over. This relentless friction, it's a process called tidal heating, and it generates enough heat to literally melt Io's insides into magma. And just when we thought we kinda had a handle on Io's ferocity, it showed us something even more intense. In late 2024, the Juno spacecraft's instruments picked up a volcanic event so powerful it completely maxed out the sensors. The energy reading was, and I mean this literally, off the charts. The eruption released more than 80 trillion watts of power. Now, to try and put that into perspective, that is 6 times the energy produced by all of Earth's power plants combined, and it's all erupting from just one spot on this little moon. This brand new hotspot that they found, it spans over 40,000 square miles. That makes this single erupting area bigger than Lake Superior. So just try to imagine one of the Great Lakes, but it's filled entirely with lava.
But here's the twist, because Io isn't just fire. All the gases being vented from its volcanoes, stuff like sulfur dioxide, it freezes instantly in the cold of space, and then it falls back to the surface as this kind of sulfurous frost, creating this bizarre, beautiful landscape where fire and ice exist right next to each other. Okay, let's leave the inferno of Io behind and travel to its next-door neighbor, another moon called Europa. On the surface, it looks like a quiet, frozen world. But beneath that ice, that's where one of the most exciting secrets in the solar system is hiding. You see, beneath its miles-thick ice shell, Europa is hiding a global, liquid water ocean, and it is vast. Scientists think this hidden ocean contains more than twice the amount of water found in all of Earth's oceans combined.
Now, this presents a really fascinating puzzle. If you've got a liquid ocean down below, how does the ice shell on top get so thick and stable? It's not like a frozen lake here on Earth. The process going on there is way more exotic. Well, the leading theory is a process that we've actually seen right here on Earth, deep under Antarctica's ice shelves. It involves something called frazzle ice, and the best way to think about it is like upside-down underwater snow. Tiny, pure ice crystals form in the supercooled ocean water, and because they're less dense, they float upwards. So what this means is that Europa's massive ice shell isn't just freezing from the top down. No, it's actively being built from the bottom up as this constant underwater snowfall rises and just freezes onto the underside of the crust, making it thicker and purer over millions of years.
And look, this discovery changes everything. Like NASA scientist Steve Vance said, it forces us to completely rethink how these ocean worlds operate. It really impacts our understanding of the ice shell's purity, its strength, and how things like heat and maybe even nutrients might move between the ocean and the surface.
Okay, so from a world of hidden ice, let's now journey to one where ice is on full display, but in ways you would never, ever expect. We're going to travel to our famous neighbor, Mars, and explore its truly alien winter. Turns out Mars actually has two different kinds of snow. The first one is familiar. It's made of water ice. But because the Martian atmosphere is so incredibly thin, the flakes often sublimate. That means they turn directly from a solid to a gas before they even hit the ground. The second type, that's snow made of carbon dioxide, dry ice, which is heavy enough to actually fall and accumulate.
But here is the most mind-bending fact about a Martian winter. Forget everything you know about the six-sided flakes we see on Earth. On Mars, the carbon dioxide snowflakes are perfect little cubes.
The shape of any crystal is just determined by how its molecules bond together. Water molecules bond in that classic six-sided pattern, giving us our beautiful snowflakes. But CO2 molecules? They bond with a four-sided symmetry, and the result is these tiny, microscopic, cubic snowflakes falling from the Martian sky.
So we've seen incredible fire. We've seen bizarre forms of ice. But why does exploring these extremes matter so much? Well, it all comes down to one of the biggest questions we can possibly ask. Are we alone?
And this brings us right back to Europa. You see, astrobiologists have a sort of checklist for places that might support life. You need liquid water, you need an energy source, and you need the right chemical building blocks. And Europa? Well, it appears to have all three. And this isn't just speculation. NASA's Europa Clipper mission is a real spacecraft, and right now, it's journeying toward Jupiter. Its prime directive, its main job, is to use things like ice-penetrating radar to find out once and for all if Europa's hidden ocean truly has the potential for life. We know that on Earth, life, well, it finds a way. It thrives in volcanic vents at the bottom of the ocean, it lives in subglacial lakes in Antarctica, just the most extreme places you can imagine. So, the final question is this. If life can exist in our planet's fire and ice, what might be swimming in the dark, vast ocean of Europa?